Hey everyone, if you're a BIM professional, you already know just how powerful a really well-built model can be. But let's be honest, what happens after the handover? Today, we're going to talk about how to stop those incredible models from becoming, well, digital fossils, and instead give them a dynamic digital life.
And this quote right here, from ISO 19650, it just hits the nail on the head, doesn't it? This is a pain point so many of us in the industry feel. We pour weeks, months, sometimes years of work into these incredibly detailed models, only to watch them become almost useless the minute the building goes live. The data gets stale, the links break, and all that value just sort of evaporates. It's a huge, huge problem.
So that's the real million-dollar question, right? How do we keep our smart, data-rich models from flatlining after construction wraps up? How do we make them living things that add value throughout the entire operational life of a building, which could be 50, 60, even 100 years?
Well, this problem actually has a name. It's called the handover gap. And it's like this giant chasm between the construction phase and the operations phase, where all that incredible as-built information just gets lost. The model becomes a static snapshot in time, a digital fossil, instead of the living tool it's supposed to be.
And that brings us to the most crucial distinction you need to understand. A BIM model, as we traditionally use it, is powerful, for sure, but it's fundamentally static. It's the blueprint. A digital twin, on the other hand, is all about being dynamic. It takes that amazing blueprint and plugs it into the live, breathing building with real-time data. It's that live connection that changes absolutely everything.
So what exactly is a digital twin? Forget the textbook definitions for a minute. Let's use a simple analogy that I think makes it all just click. What we're really talking about here is giving your building a brain. And here's where it all comes together. Your as-built BIM model, that's the perfect digital body. It has the anatomy, the structure, all the parts. The thousands of tiny IoT sensors you install, that's the nervous system, constantly feeling, sensing, and sending signals. And the digital twin platform itself, that's the brain. It takes all those signals, understands them in the context of the body, and gives you real, actionable intelligence. Okay, but this isn't just some cool sci-fi theory. It is happening right now, and it's delivering some pretty incredible results on real-world projects. Let's look at a few examples. So take a look at this number, 37.5%. That is a huge number in any context. What do you think that represents? That is the potential leap in operational efficiency for the Istanbul metro system. By using a digital twin to manage their O&M across 234 stations, they're looking at massive savings, better service, and a much more reliable system. It's a total game changer for massive infrastructure. And the applications are just so diverse. You've got museums, like the Charles H. Wright, using sensors to protect priceless artifacts from tiny changes in humidity or temperature. They're stopping problems before they can even start. Or you look at Eletrobras in Brazil. They're using AI and digital twins to predict when a critical high-voltage transformer is going to fail, preventing catastrophic blackouts. See the theme here? It's all about moving from being reactive to being predictive. All right, so you see the potential, and you're thinking, I want one. But what do you actually need to build it? Let's take a quick look at the tech toolkit. Okay, the heart of the whole operation is the integration platform. This is the software brain. You can't just plug a sensor into a Revit file, right? You need a hub that can speak both languages. A platform like Autodesk Tandem is designed specifically for this. It takes your BIM model and gives it that ability to understand and visualize all these live data streams in one place. And here's that nervous system we talked about, the Internet of Things sensors. These are really the unsung heroes of the digital twin, constantly feeding information back to the brain. We're talking everything from basic temperature and humidity sensors to vibration sensors that can tell you when a pump is about to fail, all the way to occupancy sensors that can help you optimize energy use in real time. So for all you Revit pros out there, this is the part you've probably been waiting for. How do you actually bridge that gap between your beautiful model and the real, messy, operational building? Well, it's actually more straightforward than you might think. Let's just walk through a high-level workflow. It all starts with what you already have, your as-built Revit model. Step 1, you bring that into an integration platform, like Tandem. Then you basically tell the system which parts are important. I want to monitor this pump, that air handler, and the occupancy in these 5 rooms. Step 3 is classifying those assets. Step 4 is the magic moment. You connect the digital asset to its real-world data stream from the IoT sensor. And then Step 5, you're live. You can see, analyze, and act on what's happening in your building, right there in the context of your 3D model.
Now, this next point is really, really important to understand. A true digital twin is so much more than just a cool-looking 3D dashboard. I mean, that's the start. But the real power, that lies in what comes next.
You see, a simple monitoring system is reactive. It shows you a big red light when a pump has already failed. A true digital twin is predictive. It analyzes all that historical and real-time data and tells you, hey, based on this vibration pattern, that pump is probably going to fail next Tuesday. It's the difference between insight and foresight. And this whole technology grows along a really clear path. You start at the descriptive level, that's basically your as-built model. Then you level up to informative by plugging in that live data. The next big jump is predictive, where you start using AI to forecast the future. But the holy grail, that's the autonomous twin. One that not only predicts a problem, but can automatically take action to fix or optimize the building all on its own. So I'll just leave you with this one question to think about. As you start planning your next project, think beyond that handover date. Are you just designing a building, or are you creating the foundation for a building that will have a digital life of its own? One that learns, adapts, and delivers value for decades to come. The choice is ours. Thanks for tuning in.